Well, thank you everybody for coming. So I'm here talking about the FN project. It's Oracle's take on what we should do about serverless, and how do we build sustainable services that are actually maintainable and you can actually use. But before I can say any of that, it's not a real conference or meetup in this case, unless you've seen this at least once. So read it for a moment, take it seriously in some sense. So onto the fun stuff. What is serverless? So serverless itself is, I think of it as a primitive. It's a tool that you use, or like an overarching form of tool that we use to deploy units of functionality out into a cloud, whether that's Amazon or Google or Oracle or Stackstorm or something in between on the server in the back of your house. Then it kind of comes, okay, so now we've got this notion of we want to run just bits of code without any context around them. We don't want to spend all of our time building web servers and configuring Nginx and setting up proxies and HTTPS and all of these other fun incidental complexities that we inflict on ourselves throughout the process of building applications. Like, how do we actually assemble that all together and make it so that it's something that's composable and people can actually extend later? And so that's kind of serverless as an architecture. And FAST, or functions as a service, is kind of like the real world reification of that notion of architecture, in the same sense that microservices architecture is kind of reified into reality through a platform as a service, along with some extra tools. So what does a function actually as a service system actually break down into? So we have functions, which in math are basically lists of inputs and lists of output, and which one do they go together? Now, it turns out in the real world, that's basically never what you're building. If it were, we would be done. What you usually are ending up building is something that goes and reaches out, grabs a little state here, modifies a little state there. It's something that's like a function. It's a function-ish. In the serverless land, we aspire to make our functions stateless. And the as a service bit means that you don't need to spend all your time doing plumbing and provisioning it and scaling it and patching and maintaining and all of those other things that we spend a ton of our money and thought power on. So wait, why would we want to introduce a new layer of abstraction? I mean, we remember what happened when we did microservices. We had to get rid of all those giant Ruby on Rails apps, and it took us hundreds and hundreds of hours to figure out how do we even pull this apart? Why were we doing this in the first place? There are downsides. It's tedious to do that. Even from monolith to microservice, that was extraordinarily painful. And that, again, but going from microservices to functions, it's still painful. It turns out that when you're trying to work with hundreds of people, the way that you organize those people often affects the way that you write the software. And the notion of serverless, or even microservices, is kind of contrary to how we organize our teams. So there's real costs doing this. This is a non-trivial operation. And beyond all of that, building stateless or even just immutable systems is a really difficult thing to do, because you kind of have to think ahead and say, like, what am I actually trying to accomplish? What is the minimum that I need to actually express the transformation that I'm trying to execute? We see some upsides in it, though. It can be easier in the sense that when you're building a single unit of functionality, you're not worrying about all of the incidental complexity that comes along with running a web service. It can be simpler in the sense that each one of your functions only has one focused thing that it actually does. You don't need to carry around the context of 500 other libraries that you needed for that other part of your application that other team wanted. And it is powerful in assuming you agree with the claim that things being composable makes it more powerful. If that's not your thing, then it's not really more powerful. It can be faster in the sense that you can iterate on small pieces of your application without having to redeploy the whole system. You just change that one little function out, and life is good. You can also revert much faster because your blast radius of change is much, much smaller. And it's cheaper in the sense that your metering can be much more accurate. We can measure how much resources you actually use much more accurately and bill you much more fairly. And you can pass that savings along to your customers or just to yourself if that's how you roll. So wait, I've heard that about containers. How are these functions that you're talking about, because they're not really functions, different? they're kind of a subset of containers, at least the way that FN thinks about it. We think of functions as containers that are short-running, they're ephemeral. That means they can be killed and restarted without any real problem. They're stateless-ish in the sense that, like, you go look at Amazon Lambda's like recommended, here's how you use Lambda. It says you should probably keep some global variables around that hold connections to your database and things like that. So it's not really stateless. They're invoked in the sense that they have a meaningful, like, you give it some data and it has some data on the output and there's an end. It doesn't just go forever like a web server might. You turn on a web server, it doesn't really terminate. It just goes forever. It's single purpose. It should be like a bash tool. It's like, you wouldn't expect ls to suddenly get good at sorting. And it's self-contained. It has all of the dependencies and context that's necessary to make it make sense, all bundled up with it. So, like I was saying earlier, like, what about microservices? Why don't we just stay there? It's the same question that we had with monoliths. Why didn't we just stay at a monolith? Like, that actually got some stuff done. We did the .com boom with it. It was pretty cool. It was the dream of the 2000s, microservices going from there. We're just doing it again with functions. I think that the biggest driver that pushes us to move from microservices to these functions is really those business drivers that we talked about a moment earlier about cost and easier to compose them. So with all that said, let me introduce the FN project. The FN project is an open source serverless compute platform that gives you the primitives that are necessary to actually build and run one of these, either on the cloud or on premise. It's designed to be simple by design, so you shouldn't be spending a lot of time trying to figure out how do I even put my code in here? Like, what NPM dependencies do I do? How do I do the voodoo just right so that my cloud provider actually understands how to pull my dependencies in? And then what happens when I build these native things? It's a bad news bears. We're letting you just give us a Docker container. We don't really care how you built it. We don't care what's inside of it. All we care is that when we start it, it can eat from standard in, and when it's done, it spews its result out to standard out. It's active by some definition with 2,500 commits across over 50 contributors. And we try to keep it independently governed with plans for it to be a foundation to a more enterprise focused service. So, as a developer, what does this buy you? Is this just another buzzword that you're going to have to learn? I hope not. So, like I said, FN function is just a little bit of code wrapped into a container image. It gets its input via standard in and your environment, because configuration is inevitable. It produces your output to standard out and uses STDERR for doing all of your logs. The CLI is a toolkit that you can utilize to take these bits of functionality and kind of abstract away the details of the Docker and the containers and how do I test this by just giving us a JSON file with lists of example inputs and outputs, and we'll deploy that up and validate your function utilizing those, so you get a little unit testing for free. The FN service is actually a system that you can run locally on your machine and have your entire serverless stack at your disposal, just without going out to any cloud. So what actually happens when we say FN deploy? It builds a container, bumps the version of the bit of code that you have, pushes that up to a registry, and then gives FN some metadata that describes what you asked for. And that's about it. FN service actually doesn't deal with containers itself at all. I mean, aside from pulling them and keeping them alive, like the life cycle of the container, but there's no registry inside of FN. It's bring your own registry, whatever you want. It can even be some crazy hand-rolled implementation of Docker v2. So even with all of this really nice, go standard in, standard out, it still leaves a little bit to be wanting, because it turns out that the character has lots of non-printable, or the internet has lots of non-printable characters in it, like in your HTTP responses and things like that. So there still needs to be a little bit more abstraction that we hand to the user to make it really easy to deal with these functions. So the FDKs are tools that you can use. They're language native that give you the primitives you need to easily build these functions. So it helps you out with getting the values from standard in, pushing them back out to standard out, and it gives you the ability to run what we call hot functions. So these are functions that you're explicitly saying, yes, I intend this to actually serve more than one request. Yes, I know I said I'm building a function as a service, but this one takes a while to start up. We want to run 100 times before we waste all of the startup time that we spent to get here. So the FDKs help you actually get to that point where you can build high-performance functions, not just functions. When you're debugging, this is probably where you spend 90% of your time. We have some primitives that you can utilize to make that process a much more fun and exciting process. You can ask for all of the different calls that were sent to the application. You can get logs for each one of those call IDs, and you can get detailed inputs and outputs for each one of those calls. We're also integrating open tracing into the framework, which allows you to get metrics pushed to your local Prometheus or Jaeger or whatever your preferred metric collecting system is. So when you run FN, the OSS edition of FN, on your machine, you'll get this fun little UI here. It gives you lots of metrics about what functions are running, how long they've been running for, how many functions you have running, if you've got any hot functions. We also have a notion of asynchronous functions, which are ones that don't need to return right now. Just queue up this information, handle it when you get to it, and queue up the result when you're done. And then somebody will come by and grab all those results through the async API. So for operators, is this a nightmare? Are we just, asking you to deploy Cloud Foundry again? Nothing wrong with Cloud Foundry, it's just big. So it's not too bad. We've got a load balancer, we've got some FN runners, and we've got some node pool managers. They just kind of make sure that we've got enough runners to fulfill all of your requests. The load balancer asks the node pool manager, like, hey, is there any capacity? It says, yeah, go run over here, gives that offer to the server. Server goes and executes it. Your servers have resources that they can utilize for doing object store, message queuing, and like a basic database. The actual FN server itself that the user interacts with handles all the CRUD operations for setting up your routes and your functions and keeping track of all of the massive metadata that's kind of involved in describing a service. It takes care of handling your async functions and queuing those up for you when you need them. And it's written in Go, and it's easy to extend via plugin module system. So we hope to have this extended out to all of the clouds so that you can run your FN service, a little bit on Oracle, a little bit on AWS, and a little bit on Google, and do wherever it's cheapest. Your FN load balancer is just bare minimum that you need to make sure that functions get routed to the same nodes when they're requested subsequently, and make sure that scaling happens at the right times. So this deck is actually public. You can go and check it out on deck.fnproject.io. So I'm not going to read all the details of this slide. Long and short of it is, when you ask the load balancer to go balance a request, it runs a hash on the function that you're asking to execute and consistently goes to the same server based on that. After it's done, it responds back to the load balancer, and the load balancer terminates the request. So in terms of supporting services, we have pluggable modules, so you can use different ones if you don't like the Kool-Aid we drank. Currently, we've got MySQL, SQLite, Postgres for our database. We can do Redis and Kafka for our queue. And like I said, your Docker registry can be anything. Your crazy Artifactory implementation, the one that the Scala team wrote, who knows. So in terms of metrics and monitoring, we've actually integrated open tracing not only into the CLI so that you can see how long it takes to ask for operations on FN, but we also have integrated open tracing to some degree into the actual execution context of FN. So you get a little bit of metrics and monitoring for free when you're running your functions. All of your logging is done via syslog. and it's all supported by Prometheus. So you get some cool dashboards for free, kind of. I hesitate to say free because you still need to run your Prometheus cluster, and that still takes time. So with all of this, how does that actually end up working when we want to get all of that provisioned and make sure that when we ask for a request, we can use a hot container when we want to, or use a cold container if nobody's asked for that a long time? The flow is not particularly complicated. Like we talked about with the router that actually does load balancing, there's another layer of logic that talks about how to make sure that the containers are present on the FN runners themselves. So the runners themselves are actually responsible for doing the polls. They're given the metadata to execute that, and they go and do the Docker poll, then execute your function and stuff your result back. The synchronous request, again, check out the docs for more details. When you're scheduling a hot function, it will go through and start to queue up a list of what you've asked it to invoke over the last period of time, however long your hot function expiration time is. And it ends up so that you have containers attached to each slot in this queue that are getting ready to warm up. It's queued up all of the requests into the message queuing system. And then as these containers become warm, they actually go and execute the requests and fulfill the contract that they're abiding by. And that's how that works. So how does all of this stay turned on? Because clearly there's a lot of complexity there. There's tons of little pods of servers that we're working with, and they all have to be resurrected if they die, and infrastructure doesn't stay turned on. It never happens. So we utilize Kubernetes, which is incredibly good at guaranteeing reliable services given a declarative description of your service. So the FN scheduler is pretty agnostic. It works hard to not assume that the system is running on top of Kubernetes. We've built a Helm chart that describes all of the bits and pieces, so you can just run your Helm chart, installs on your Kubernetes cluster, and you're ready to go. We're looking at how to do deeper integrations with Kubernetes so that we can make it a little bit smarter about how it schedules its pods out. So the actual deployment ends up being a few pods. You've got your load balancer pods, and you've got your FN runner pods, and then you've got your dependent service pods down at the very bottom that actually serve your database and message queue and things like that. So it kind of brings the question wait, why not just use kubeless? That already existed. Kubernetes is you're using Kubernetes. Why isn't it good enough for me? I think it comes down to Kubernetes is designed to be reliable. That's its goal in life. It's not supposed to be fast. It's supposed to be as fast as it can be, but it's not supposed to be fast first. So we think it makes sense to build an abstraction on top of Kubernetes reliability to make it so that we can very quickly execute the functions that you ask us to, and return those results. And the other piece is scale. You don't want every one of your functions to have its own IP address. That's not really going to work out super well when you have 100 million functions. So that's our case there. All of this is, of course, built on top of Docker. We've tried a lot of different ways of making it work well on Docker. We found that overlay FS2 was really the best option for us. The rest of them had some issues. We also use Docker and Docker on our runners themselves. The reason why we do this is to make it so that the opinions of the customer have as little of a blast radius as possible on the rest of the service. So it turns out that customers sometimes like Docker version 1.9. You don't know why, but they want it. So we want to give them a way that they can have their own little special Snowflake version, isolated away from the rest of our infrastructure and isolated away from our operations people. So we utilize Docker and Docker to make that happen. It also gives us a fun benefit that systemd can manage FN pretty nicely, because there's just these top-level Docker containers. You say, keep these alive, and it does. Yeah, so one last little treat is fmflow, which is one of the first what I call new abstractions that we built on top of fn that allows you to describe a long-running scalable function that uses your language-specific primitives, whether fork, join, or chaining, or delays, like promises. And it basically automatically builds those fn blocks for you. So in Java, anything that has the completable future API implemented on it can be turned into a fn function trivially. So to kind of show this, let's imagine that we want to build a Flickr scraper. And when we build this Flickr scraper, we want to find any nice plates, like the backgrounds that we'd use to put some like fun, impressive text on top of. And then we want to draw, a tweet onto that plate and then post it onto Twitter and post it onto Slack so we can annoy all of our coworkers. So the first bit here is we invoke a scrape on Flickr. Then we compose the result of that with a function that goes and grabs that plate detection to see if it's one that we want, and another function to actually do the drawing. And then once both of those are finished, we want to go and post to both Twitter and Slack. All of this logic ends up being kind of shoved down into one page of code. You're able to go through and just grab your scraper, just call it by name, and then when that's done, you are returning your detect, plate, and draw functions, which is finally returning the end of your flow, which is waiting for those to finish and invoking functions to take that information and put it on top of Twitter and Slack. When it's done, you can react to that because it's important to be able to do things when other things are done. And that, is the extent of that implementation. So we kind of see the abstraction of the FM project kind of going from fmflow and those sorts of abstractions where we're able to do more complex things in much more succinct ways on top of these FDKs, which live on top of the FN kind of serverless world. So thank you. If you have any questions, you can send me an email at eric.fode@oracle.com. We've got a great public Slack. You should come and join it. Ask any questions you have, or if you have any ideas, we'd love to collaborate with you and make our project better and easier to use for everyone. So thank you.